Hello students, so I hope you have revised the formulae that were explained and derived in the last session. Today we will do numericals on that. First, numericals on this page are quite simple. You have to only write the formula and put the values to get the answer. Like the first question is, what potential difference is required to make a current of 1 ampere? So I is 1, flowing through resistance of 25 ohm. So R is given, I is given, I want to know V. So to know the formula, V is equal to I multiplied by R. Substitute the values I as 1, R as 25, so you get 25 volt. Is it okay? Now second sum. What current flows when a potential difference 20 volt? So PD is 20 volt, is connected to a resistance 1 kilo ohm. 1 kilo ohm means 1000 ohm. So I know R, I know V, so I will write the same formula, V is equal to IR. Make I as a subject, I will get I is equal to V upon R. Substitute the values, will get the answer. Next, third sum. A 1 meter length of wire. Now the length of wire is given, is having a resistance of 40 ohm. What would be the resistance of the same wire of length 5 meter? So when it says same wire, so it means area of cross section is same and material is same. So only I am making by length as 5 times. As we know, R is proportional to L. R is proportional to length of the wire when area of cross section and specific resistance are same. So using this, I will get the answer R1 upon R2 equal to L1 upon L2. L1 upon L2 is 5 upon 1 and 1 R is given, so I will come to know the other R. Is it alright? Then what would be the resistance when area of cross section is half? So area of cross section is half, material is same, length is same, so R is inversely proportional to the area, so area has become half, so resistance will double. So instead of 200 ohm, it will become 400 ohm. Is it alright? Next, now gradually the difficulty of the sum will increase. 310 ohm resistance. So this data is given in words. Sometimes you miss, are connected in series. So when connected in series, R is equal to R1 plus R2 plus R3, all are 10. So 10 plus 10 plus 10 will give 30 ohm. So resistance of this wire is 30 ohm. And power supply 24 volt. So I know V, I know R, I want to find I. So I is equal to V upon R. So substitute the values, will get the answer. Is it alright? Next, this is important. 250 ohm and 110 ohm are connected in parallel. So this is 150 ohm, this is another 50 ohm, and this is 10 ohm. All are connected at this and at this point, at this and at the, or you can say this point. So the current will come and will divide. Here we will have some power supply to them. Okay, so these resistances are connected as parallel, 50, 50 and 10. Is it alright? Okay, so in parallel you know the formula, 1 upon R is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So this formula we will use. So R1 is 50, R2 is 50, this is 10. So this is simple arithmetic. You calculate, you will get 7 upon 50 because 50 will be the LCM, 10 into 5 is 50, so 5 plus 1 will be 7, denominator is 50, so we'll take the reciprocal, so we'll get R equal to 50 upon 7 ohm. Okay, note down. Next, PD across each is same, 12 volt. Always in parallel PD is same, so that is given to be 12 volt. It says calculate the effective resistance and current through each. Now, if current through each means current through 50 and 10 ohm. Through both 50 it will be same. Current V is always same. So across 50 ohm V is 50. So current is V upon R. Current is V upon R. V is 12 volt. This is 50. You will get 0.24. So through each 50 ohm resistance, current is 0.24. So here the current is 0.24 ampere. Here the current is 0.24 ampere. Now we will find the current through 10 ampere. Through 10 ampere current would be also V upon R. So 12 upon 10, so I will get 1.2 ampere. So total current that comes is 1.2 plus 0.24 plus 0.24. So I written 2 multiplied by 0.24 plus 1.2, so we will get the answer as 1.68. Is it alright? You can note down this. Then we will go to next sum. Now you see, this sum, these are called series parallel. This is 7.2 and these two parallel, I can find one effective resistance of this. So then that and 7.2 becomes in series. Okay. He says find the resistance of the circuit, total current in the circuit and PD across 7.2. So this is 7.2 in this diagram. So first we will do this. What is the current in this 7.2? So first how to find equivalent? So first I will find equivalent always of these two parallel. So I will get 1 upon R equal to 1 upon 12 plus 1 upon 8. If you simplify this, you will get 4.8, or you can also could have calculated R is equal to R1 R2 upon R1 plus R2. Okay, so you will get the value of R as 4.8. Now 7.8, 7.2, and in this place this can be replaced by 4.8. This can be replaced by 4.8. Then this and this becomes in series. So the resistance will become 7.2 plus 4.8, that I am getting as 12 ohm. So now I know the effective resistance. So what is the current through the circuit? Current through the circuit would be, now I have got the equivalent. So means I have got this one resistance and one battery. And this is remain at 6 volt. And this I have got as 12 ohm. So this is 12 ohm resistance. So I can calculate the current through the circuit. So current through the circuit will be V upon R. So I am getting 0.5 ampere. So that is the current coming from the battery here. 0.5. But the same current will pass through 7.2. Here the current will split. So potential difference of 7.2 would be 7.2 into current as 0.5. I will get 3.6 volt. So here the potential difference 3.6 volt. If they would have asked what is the potential difference here, we could have done in the same manner. Then 6 minus 3.6 will be 2.4. That will be across this parallel combination. Okay, this is very important sum. Such sums do come in exam. So whenever series and parallel are given in this manner, get equivalent of this parallel. This becomes in series. Get the value of R. Get the value of current. Current will split here. Okay? Then we go to next sum. He says current through 5 ohm resistance. Now here his data is given in figure. This is 10 volt and 5 ohm. This here the voltage drop is 10 and resistance is 5. Here I have given only the voltage. R is question mark. That is the question. Find unknown resistance and PD. So I have to calculate this V. So this V and this R is to be calculated. So here you will see I know both the things. I know V as well as R. So if I know the two things, I can find the third thing. So I can find the current. Current would be I is equal to V upon R. So current would be I is equal to V upon R. So I will get 2 ampere. So the current is 2 ampere through here. Now here the current is 2. These two are in series. In series, current remains same. So here also current is 2, voltage is 6. So I come to know R. R is equal to V upon I. V is given to be 6 volt, current is 2 ampere, so resistance is 3 ohm. Now once I know then he is asking what is the potential difference developed. I know this is 10 volt and this is 6 volt. So PD developed by this is potential difference drop across this resistance plus PD drop across this resistance. So it will be 10 plus 6, 16 volt. So PD developed by the battery is 16. It is giving 10 to this and 6 to this. Is it alright? This is quite important. This point you should note. So let us do last 3 sums of the day. Sum number 8 reads, there is a copper wire of length 2 meter. So I have been given length as 2 meter. Area of cross section is given 1.7 10 raised to minus 6 square meter. And resistance is given 2 into 10 raised to minus 2. So I have to calculate the resistivity. So this is very simple. Write the formula. R is equal to rho L upon A. I want to know rho. So rho would be RA upon L. So that's what I have written here. Substitute the values, you will get the answer. In this sum, values are also given in SI system. Square meter, meter and ohm. So resistivity you know is ohm meter. Now 9th sum. A copper wire has diameter of 0.25. So this is very important to note. This sometimes gets missed by some students. Diameter is 0.25. So radius would be 0.25 millimeter. This is very important. We cannot substitute in millimeter because we are doing the sum in MKS. So we should write radius is 0.25 into 10 raised to minus 3 meter. So this is my R. So my R is equal to 0.25 into 10 raised to minus 3 meter. So my area would be pi R square. So this is my area. Now resistivity is given, resistance is given. Those things are in SI system. So now I want to find length. So length from this formula you will get L is equal to RA upon rho. So R will substitute whatever the value is given in ohm meter, 1.6 10 raised to minus 8. Area you will do pi R square and we have to take 0.25 into 10 raised to minus 3 as the radius. So area would be pi means 3.14 into R square of this and rho is given to you. Rho is given 1.6 and 10 raised to minus 8. And R is given to be 10 ohm. This is my resistance. This is my R. This is my rho. And from here calculate the area. That will get the answer. Okay. This is how much does the resistance change. Diameter is doubled. Now you see diameter is doubling. We have learned that resistance is proportional to 1 upon area. Now 1 upon area means, so I can say R is proportional to 1 upon D square. Area is proportional to D square. Area is equal to pi D square upon 4. Area of a circle is pi D square upon 4. These are constant. So area is proportional to D square. So R becomes proportional to 1 upon D square, or R is inversely proportional to D square. So if I am doubling the diameter, means this will become 4D square. So my resistance will become 1 upon 4. So R will become 1 upon 4 times, not half. Okay. Next sum. 6 ohm resistance. So this is R. Is 6 ohm resistance is doubled up by folding. So this was my length. Now I have folded it like this. So when I have folded it like this, so my length will become L upon 2. And area of cross section A2 would become 2A. 2A1. First one, if the first one area was A1, and my L2 is L1 upon 2. Initially I had length L1, area A1. Now my new area is A2, which is 2A1. New length is L2, which is L1 upon 2. So knowing previous things, I can calculate by taking the ratios, because resistance was R. So initially R1, my resistance was R1. What is R1? Rho. Rho into L1 upon A1. And now second, my resistance with that of R2 is equal to rho L2 upon A2. So take the ratios R2 upon R1. So if I take the ratios R2 upon R1, I will get rho will get cancelled, L2 upon A2, and here I will get L1 upon A1. So you can put the values and get the answer. R1 is known. Okay. So in this manner, you have to do practice doing numericals, because definitely one numerical is asked from this topic. I hope you have understood, but you should do practice, and not only for the sums which I have done, but from the reference book and textbook. In case any difficulties, you can ask me. If you have not subscribed so far, you can subscribe the channel and like the channel and press the bell icon, so that you will get notification when new video is posted. Thank you.